A third way to create vectors is using this function, this built-in function called linspace, which refers to a linear spacing of the elements in the vector. And so once again, I'm going to use capital letters for vectors, and that's just for this exercise because I think it gives more emphasis. So if I do vector A, and that equals linspace. So what it's going to do is you give it the lower limit, or you can think about that as the start value as well. You give it an upper limit, and unlike in range, this upper limit will be obtained, and so this upper limit value will be in the final vector. And then you give it the number of values that you desire to be in that vector. So let's see it in action here. If I do linspace, lower limit 1, upper limit 10, and then the number of values to be 10, it's going to give me 10 evenly spaced values starting at 1 and ending at 10. And so this is going to be the equivalent of if I had written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 values evenly spaced between starting at 1 with a lower limit of 1 and an upper limit of 10. Now let's do B, another vector, linspace 1, 10. So we're going to start at 1, end at 10 again, but this time we're going to, let's just put a 2 in there and see what happens. Okay? So we got 2 values starting at 1, ending at 10, evenly spaced between 1 and 10. Well, that only gives us that. That's the vector 1, 10, because those are 2 values in the vector evenly spaced between 1 and 10. Let's do another one. Now with all of these things that I'm showing you, I'm assuming that you're also going to open up MATLAB and try this stuff and play with it, and that's the only way you're going to become comfortable with it. So let's do this one, lower limit 1, upper limit 10, and then let's do 4 evenly spaced values. So that's going to be 1, 4, 7, 10. Now look at that. There's a value of 3 between each of these. So these are 4 values, lower limit 1, upper limit 10, evenly spaced between 1 and 10. Let's do one that's not so clean and involves decimal numbers here. So I'm going to do linspace 1, 10, 5. And so that's going to come back and give the vector 1, 0.00, comma 3.25, comma 5.50, comma 7.75, comma 10.00. Now that's 5 values, 1, 2, 3, 4, 5, starting at 1, ending at 10, evenly spaced. So there's 2 1/4 between these, 2 1/4 between these, 2 1/4 between there, and 2 1/4 between there. So that's the idea of linspace. Is once again, you have a lower limit, an upper limit, and you give it the number of values you want, and then MATLAB automatically creates this evenly spaced vector. But the thing to really note is that this end value will be included in the vector. Okay, so that's the concept of linspace. Moving on, so those are sort of the 3, basic ways that we create a vector. And I'll summarize over here. You can do direct entry. You can use the range, which you'll use the range a lot in the course of the class. And then you also can use this function called linspace, which we won't use as much, but does come in handy in a lot of places, so it's good to know about it now. So those are the main ways that you can create a vector. Now, with that said, there are other ways to create very specialized vectors. Let's talk about the command zeros, and actually it's a lowercase z, zeros. This will create a vector that contains nothing but zeros, but this is actually helpful. Now, the trick here is the command looks something like this, or it looks exactly like this. Zeros. If I wanted to create a vector with 5 zeros in it, I would do zeros 1, 5. Now, what does the one, why are there two numbers here? This first number represents the number of rows in the vector, and the second represents the number of columns in the vector. Now, remember earlier when I talked about this concept of vectors, arrays, and matrices? Okay, so vectors can be multiple dimensional. We've just, the way we think about it in terms of MATLAB is vectors usually only have one row. So it's one row and then multiple columns in a vector. So vectors are sort of the subset of arrays and matrices in the fact that they're one-dimensional. We can make multi-dimensional things here, but right now we're trying to stick with the basics. So we're going to stick with one row and multiple columns. Well, if that be the case and we're just dealing with vectors, then over here, this is why the function 0 takes in, it can do multi-dimensional arrays and matrices. But what we're trying to do is just do a vector. So a vector only has one row. And if we wanted this particular vector A to have 5 zeros, then we do one row and 5 columns, and then it would fill it with zeros. So this would actually result in A looking like this. Okay. Likewise, there is a function called ones, which does exactly what you think it should do. If I had vector B and I used ones, 1, 5, then it would create a vector with one row of ones. Okay. Another thing to do is random. Sometimes you want a vector with nothing but zeros in it. Sometimes you may want a vector with nothing but ones in it. And then sometimes you want a vector with random numbers in it. And so the way you do that is with a function called rand, R-A-N-D. And if you did random 1, n, it would actually give you a vector of random numbers between 0 and 1. Okay, and I think it's inclusive. I think it actually will give you numbers that are greater than or equal to 0 and less than or equal to 1. So it'll give you numbers in this range here. So if you did random 1, 5, you would get a vector of random numbers. In fact, you would get, if you typed it into MATLAB, you probably would get these numbers. Now, this always brings up the question, well, wait a minute. They're supposed to be random numbers, but Cedric, you typed them into your computer and you got these numbers, and I typed them into my computer and got the same numbers. How is that random? It's random relative to your particular installation of MATLAB. There's a thing called the random number generator, which is the same for all the versions of MATLAB, and so when you start it, what it does is it generates the sort of the same list of random numbers. And so that is why when you type this into MATLAB, you probably got the same thing that I got here. But this is a list of random numbers between 0 and 1. And you can do various math operations to create a list of random numbers between any values that you want. And we'll talk about that a bit more. In fact, that's a very good exercise for you to try to do, is to create a vector of random numbers between two particular values. So let's recap again. Sort of 6 ways that we talked about creating a vector. We have direct entry, we have range, which once again is going to be extremely important as we go forward. We have linspace, and then we have zeros, ones, and this random operator. Okay, and so we can master these, then we'll be able to create any vector we want. And then understanding that vectors are one-dimensional, we'll get into multi-dimensional stuff later. So that's creation of vectors. Next, we're going to look at some operations on and with vectors. So now we're going to pick up where we left off with vectors and defining vectors, and I'm going to use now, excuse me, a function known as linspace. And let's type it in here. I'm going to use a function now known as linspace. And so let's define, and what you see here, I've left the direct entry and the range up, and now I'm going to use linspace here. So I'm going to create a vector, and let me hold a little bit true to the onboard stuff that I did. Since I've commented out the values of A, B, C, D, E, and F here, then they won't show up in what I run over here. And run down here. So I'm going to say A equals linspace. Keep in mind the whole format is lower limit, comma, upper limit, comma, number of values that you need. So that's sort of how you format a linspace statement. So let's see it in action. And I'll say vector A equals 1, comma 10, comma 10. I forgot a parenthesis here. And I'm actually not going to suppress this because I want to see the vectors down here. So I'm going to execute this, and there's an error somewhere. Oh, didn't type in linspace. So now you get to see what happens when you get an error. It dings at you, and you get red text here. So I typed in linspace, and once again, I did not put the semicolon, so I should see my vector A down low in the command window. So I hit it, and there you go. So vector A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again, it has a lower limit of 1, an upper limit of 10, and has 10 values. And so these are 10 evenly spaced values between there. Now let's see what happens. I'm going to suppress this one, and look and see what happens when we define vector B as linspace 1, comma 10, comma 2. And so what this is saying is that lower limit 1, upper limit 10, and then 2 values evenly spaced between the two. no semicolon, so it should show up down here. The semicolon on line 18, variable A, will prevent this from showing this time. And so if I run this, I get B equals 110, and that makes sense. And you can look over here in the workspace and see these vectors being formed as well. So that makes sense because I have start at 1, end at 10. There are two total values evenly spaced, and there you go, 1 to 10. Let's go to vector C, which I covered on the board as well, equals length space. I'm going to start at 1, end at 10, upper limit is 10, and we're going to do 4 values that are evenly spaced. Once again, keep in mind that with length space, the upper limit will always be included, as opposed to range, as we had in this example here with D, the upper limit or the stop point may not be included. So when I run this one, I get vector C is 1, 4, 7, 3. 4 values starting at 1, ending at 10, evenly spaced. There are 3 units between each one of these. Moving on, we define vector D, space 1, comma, 10, comma, 5. Run that one, you get D equals, whoops, C looks sort of funky there because I put an apostrophe. That's way more advanced than we need to get to, but the apostrophe does sort of transpose your vector, but that's much more advanced than we get to in the next 4 weeks. But anyhow, D, as you see here, is 1.0, 3.25, 5.5, 7.75, and 10. Each one of these are spaced 2.25 units apart. And so 5 elements starting at 1, ending at 10, evenly spaced apart. And so once again, you can see the vectors up there, up here in the workspace window. All right, so that's lens space, and that's how you define vectors with lens space. It can come in handy in a lot of different areas when you need evenly spaced out values. So that's lens space. Now we're going to move to some sort of what I call sort of, quickie functions. There may be some time that you need to define a vector with only zeros in it. So we'll make vector E equal to zeros. Now, with the function zeros, you have to give it a row and a column. So let me come up here and make some comments. So if I define E as zeros, 1, comma, 5, what I'm saying actually is I'm giving it the number of rows and the number of columns that I want in my output. Now, zeros will create arrays and matrices. That's why it does 2 dimensions. Keep in mind we said earlier that vectors are one-dimensional. They have 1 row. So right now, when we use a function like zeros and its counterparts 1 in random, which we'll see in a second, we have to define a number of rows and columns, but we're always going to use the value of 1 here for the rows because remember with vectors, they only have 1 row. So when I do this, it's simply going to create a vector, and I'll leave the semicolon off here as well. It will create a vector that has 5 zeros in it. Okay. Likewise, there I can do vector F, which is 1, comma 5, and as anticipated, it creates a vector with 5 1s in it. And then the last one I'm going to do is random, which sometimes it's beneficial to create random data. And so what random is going to do is it's going to create values that are between 0 and 1, and I believe that's inclusive. So it is possible to get a 0 or 1, but it creates values in that range there. And so, so let's do vector G equals RAND, which is a random function, and if we go 1, 5, 1 row, 5 columns, and there you go. These are random values. If you start MATLAB over again, if you and a friend start MATLAB at the same time, you will get the same random values, and that's just because the random number generator within MATLAB starts off in the same point, which is sort of an interesting thing. So those are the ways that you can create vectors. Keep in mind, in recap, you can do direct entry, you can do range, linspace, and then if you need to do this specialty stuff, you can do zeros, ones, or random.